All right, so this video is going to go over pages 14 through 16, kind of going over kinetic energy. So kinetic energy is the energy due to an object's motion. So you have to have motion in order to have kinetic energy because kinetic means movement. As all objects have mass, any object with a velocity has a kinetic energy of the product of 1/2 the mass and the velocity squared. All that's basically telling you is the equation. So kinetic energy, Ke, equals 1/2 mv squared. Okay, mass times velocity squared. Note the kinetic energy is directly proportional to the mass and directly proportional to the velocity squared. So that basically means is if I increase the mass, so let's say my mass goes up, let's say I double it. Okay, my kinetic energy is going to go up as well. So it's directly proportional and it will go up by 2, so it'll double as well. Now, as far as velocity goes, so since that velocity is squared, if I increase the velocity, so let's just say I double that, okay, what's going to happen to my kinetic energy is it's actually going to quadruple, okay, because that squared is there, okay, it's going to make it go up by 4. So mass is direct, so if I double mass, my kinetic energy doubles. Velocity is direct, but to the squared version. So if I double velocity, my kinetic energy actually increases by 4. So the first example says, what is the kinetic energy? So that means I am looking for Ke, okay, of a 12 kilogram rock rolling at 3 meters per second. So mass is 12 kilograms, velocity is 3 meters per second. So my equation, so Ke equals 1/2 my mass, which is 12. My velocity is 3, and that is squared. So just squaring the velocity, please do not square the mass. That comes out to be 54 joules. Next one, it says, what is the speed? So that means velocity is your question mark. I have a 170-gram baseball. Okay, so that does me no good. So 170 grams, I need to fix that. Okay, I need to get to kilograms. So remember, just divide by 1,000. And that'll get you to a kilogram, so that's 0.170 kilograms. And I told you kinetic energy is 110 joules. Okay, so now I'm going to plug in. So kinetic energy I know is 110 equals 1/2. My mass is 0.170 and velocity squared. Okay, so that's basically going to come out to 1,294 equals v squared. Okay, so I can't leave it as v squared, so I need to get rid of a square by doing the square root of both sides. When you do that, the square and the square root cancel out. So the square root of 1,294, so my velocity comes out to be 36 meters per second. Okay, moving on, next page. The work energy theorem. So recall, work is a change in transfer of energy. So work done on an object is equal to the change in kinetic energy. Well, since kinetic energy is energy and work requires energy, that means you can basically set them equal to each other. So work equals your change in kinetic energy. Okay, now work also equals force times distance, and your change in kinetic energy. So change means final minus initial, can be 1/2 mv final squared minus 1/2 mv initial squared. So since those both equal each other, I can set those two equations equal to each other. So force times distance equals 1/2 mass times velocity final squared minus 1/2 mass times velocity initial squared. Okay, so that's a big equation. Usually you'll know when you're going to need that because you'll be given a lot of stuff. And we'll see that just here in a second. So it says how much work is being done. So work, I don't know. When a 5,700 kilogram truck, so I just gave you mass, speeds up from 50 kilometers per hour to 75 kilometers per hour. So V1 or V initial is going to be 50 kilometers per hour, but I can't have that. Okay, I need to get to meters per second, so divide it by 3.6, and you get 13.9 meters per second. And your V final is 75 kilometers per hour, so we're going to fix that. So 75 divided by 3.6, that gives me 20.8 meters per second. Now, I just want to know what work is. So remember, work equals that change in kinetic energy. So work equals 1/2 my mass, which is 5,700, times velocity final squared. So final is 20.8 squared minus whatever your initial was. So 1/2 my mass is still 5,700. But now my initial velocity is 13.9. Okay, so after you do all that math, you should get an answer. It's going to be a big answer because you're dealing with a big truck with a lot of mass and a lot of speed. Okay, it's going to come out to 682,375 joules. Remember, the unit for energy is joules. Next example, it says, what is the stopping force? Okay, so I don't know force. Of a 30 kilogram object, so mass is 30 kilograms, that started at 10 meters per second, so VI is 10 meters per second, and stopped. So stopped means your V final is 0, and your distance was 15 meters. Okay, so you'll notice you have a lot of stuff going on here. Okay, so when you see a lot of things you're starting to fill out, that's kind of a hint to use this equation. That is going to be that F times D equals 1/2 mv final squared minus 1/2 mv initial squared. Now, good news is since VF is 0, that means you can go ahead and get rid of that whole first part of the change in kinetic energy. So force, I don't know. Distance is 15 equals 0 minus 1/2. My mass is 30 kilograms. And VI is 10, and that is going to be squared. Okay, so that comes out to basically be F times 15 equals negative 1,500. I'm going to divide both sides by 15, and my force comes out to be a negative 100 newtons. Okay, so it is okay to have a negative force because remember what it's doing is it's stopping you. Stopping is going against the direction that you're going. Okay, so negative is okay. So moving on to the next page. In what time and distance, so time I don't know, distance I don't know, can a 1,000 kilogram car stop? So mass is 1,000 kilograms. V final is going to be 0 since I'm coming to a stop. My V initial is it's because moving at 30 meters per second. And it has a 3,000 Newton braking force. So braking means it's stopping, so I'm going to go ahead and make that a negative, so negative 3,000 newtons. Okay, so this one kind of goes back a little bit to that whole impulse momentum from last unit, so impulse momentum theorem. Okay, so remember, force times time equals mass times V final minus V initial. Okay, now I would probably bet that on your test and stuff, you're probably not going to dip too much in impulse momentum. Okay, but some of this stuff can come back. So my force would be negative 3,000. Time, I don't know. Okay, my mass is 1,000. Okay, V final is 0 minus my initial velocity, which is going to be 30, and solve for t. So divide both sides by negative 3,000, and you should get 10 seconds. So there is your first answer right there. Now the distance part, I can do that of what that's just what we went over. Okay, so remember, force times distance equals 1/2 mv final squared minus 1/2 mv initial squared. But since I'm coming to a stop, that whole first part of the V final goes to 0. So my force will be negative 3,000. Distance, I don't know. I'm going to leave that as D. Equals 0 minus 1/2. My mass, still 1,000. My V initial is 30. And that's going to be squared. So basically, solve for D, divide both sides by negative 3,000, and you get a distance of 150 meters. Okay, let me clear all this. I don't know where that came from. Okay, so next problem is in what time and distance in the car can the car in the previous question stop if moving at 60 meters per second with the same braking force? Okay, so basically what we're going to do is we're going to do the same thing, but now I'm moving a little bit faster. Okay, so that first step we did is we did force times time equals mass times my change in velocity. Okay, so my braking force is still the same, so that's going to be negative 3,000. Time I don't know. Mass is still 1,000. V final is 0 because we're coming to a stop. Minus, now I have a higher speed of 60. Okay, solve for t. So t is going to equal out to 20 seconds. Okay, so if you notice that, my velocity went up by 2. I doubled it. And if you look at the times from part A, or the last question in this question, it went from 10 seconds to 20 seconds. So that doubled as well. So basically if I double the velocity, my time is going to double as well. Now, as far as 2, so step 2, we're going to use that same F times D, so negative 3,000. Distance I don't know. Equals negative 1/2. Oops. Times my mass, which is 1,000. Times my velocity is now 60, and that is squared. So solve for D, divide both sides by negative 3,000, and I get a distance of 600 meters. Okay, so if you look at your first distance, I was at 150, and now I'm at 600. So that means if my velocity went up by 2, let me fix that. If my velocity went up by 2, my distance actually went up by 4. Okay, because remember that velocity is squared, and if you double that velocity and then square it, it's actually going to quadruple that stopping distance. So the time would double, but the stopping distance would quadruple. Okay, and that'll stop for this page.